Um, for today's lesson, we're going to take a look at dot plots. Another way to visually show graphs in statistics, right? We've seen box plots, we've seen um, histograms, we've seen scatter plots, right? And here's just another one to add to the list: dot plots, and they're fairly simple. They kind of look a little bit like histograms, but without the bars, right? They're going to be represented with dots instead, and they're not going to connect. They're just it's going to have kind of near the same layout. But let's get into it. Let's take a look at the first example that we have here. So here's your classic example of a dot plot, right? So you got your nice number line here, 0 through 6, and you got dots representing each number. And this example is saying the students in one social studies class were asked how many siblings they each have. The dot plot below shows the results. And then it's got these three questions. So, part A, how many of the students have 6 siblings? Okay, so we take a look. These numbers here, this represents your frequency. How many times it occurs. Oops. So this is your frequency list. How often does it occur? Right, and it's kind of self-explanatory on how to read it. So how many students have 6 siblings? Well, I'm going to look at 6, and that means that there's one dot here. Well, that means that one student has 6 siblings. Right, not too bad. Second question, how many students have no siblings? So why don't you guys go ahead and do that. What's the answer to part B? How many have no siblings? 0 siblings is here. I got 1, 2, 3 dots. So 3 students have no siblings. And then part C, how many of the students have 3 or more siblings? So it's saying 3 or more. So that's going to include 3, 4, 5, or 6. Right? So I got to include this, 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 and this. So let's count up the dots. Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. None for 5. And then this dot would make it 11. So 11 students have 3 or more siblings. Right? And that's the general overview of what the dot plot looks like. Okay, it's not too bad. Let's go on to the next page. So here, this nice little figure here. I know we talked about skewness with box plots, but this is a great way to also visualize symmetry and skewness. So the shape of a dot plot can be either symmetrical or skewed. So here, this first example, this is saying most of the data is near the center of the range. So this shape is symmetrical. Definitely is, right? It's leveled out, goes up, and then goes back down. Very leveled out. The second example here, it says that the dot plot has a tail on the left. Remember, which way does it look like it's going down towards? I kind of, when I'm looking at dot plots, I kind of think of it like a slide. Right? If I'm sliding down to the left, that means I am skewed left, or left skewed. Okay. And then oppositely, if I am starting on the left and then going down to the right, I'm on a slide, I'm going down to the right, or I'm on a mountain or something, that means that this is skewed right, or right skewed. All right. And then I want you to get these notes down. So these are important little bullet points that I included here. So make sure you get all these down, okay? Um, let's go here. When the distribution is nearly symmetrical, right? So this yellow highlight, looking at something like this. The mean and the median of the distribution are approximately equal, okay? A symmetrical data set means that the mean and the median are approximately equal, and that's good. That's what we want. That's a good looking data set there. When the distribution is not symmetrical or it's skewed, like this example or this example, then the mean and the median are not equal. They're not the same or equal, right? And that just makes sense because obviously if symmetrical, the mean and median are approximately equal. If it's not symmetrical, well then they're not going to be equal. And we kind of went through these next 2 points back when we did, I believe, which lesson was it? I believe it was just learning about mean and median, just central tendencies. So for symmetrical distributions, like for this yellow one, right, for symmetrical distributions, the blank is an appropriate choice for describing a typical value of the distribution. In other words, what's the best measure of central tendency? We learned about this. There's only two that we would choose from. We would either choose from the mean or from the median. And if you have a symmetrical distribution like this one, the mean is an appropriate choice for describing the central tendency. You would want to use the mean in this case for your central tendency. Now, if you had a skewed data set, like the one in green or the one in blue up here, if you had a skewed data set, then you would want to use the median as a better measure of central tendency. Okay, the median is a better description for the measure of central tendency. And also remember back to when we did this. You want to use the mean if there are no outliers, right? That's always something you want to remember. But you want to use the median if there are outliers. All right? Because if there's an outlier, right? If I had say I had, how would I even show this? Say I had a dot plot that looked like something like this, and then I had two outliers over here. Right? If these are our outliers. And if we have these, that means that it's going to skew our data set all the way to the right. Right? It's going to skew our data set all the way to the right. If I kind of looked at that, it's kind of like a slide going down. And again, if it's skewed, you're going to want to use the median because that means that there's an outlier. Outliers mean skew. Not all the time, but usually most of the time that's what it means. And if you have no outliers, then you want to use the mean. Okay. Now let's look at example 2. The heights of 20 basketball players in inches are given below. And we got all these nice data points. Construct a dot plot using the number line below of the data. Okay, that's pretty simple. So I want you guys to pause this video, get down the number line, and then I want you to follow along as I construct this dot plot. When you construct this dot plot, I recommend you use X's, okay? Use X's instead of dots. It's much easier to see and you won't get confused by looking at it, okay? So as I go to construct this, I'm going to start with this first one, 68. Okay, I find 60 at my number line. I'm going to put an X. Then I go to 70. And then I says 70 again. Okay, so I'm going to have another X on top of that 70. I'm going to keep following this until my dot plot is constructed. Okay, so I got my dot plot constructed here. It looks like this. Very nice. Number one, what is the mode of the data? Answer that now. What is the mode? Remember what that word means. Again, anytime I see the word mode, it reminds me a lot of the word most. Which number occurs the most? 75 occurs 5 times, and that is more than any other number here. 75 is my mode. Then it says, what's the range? What is the range? Remember, the range is max minus min. The highest minus the lowest. That means I'm going to have 84 minus 68. And what is that going to be? Well, I believe that's going to be 16. Pull out your calculator and do that as well. And then it says, what is the median of this data set? What's the median? Well, looking at this dot plot, can't really tell what the median is, right? My numbers aren't listed in order. I didn't put into the calculator. So what I'm going to do, and really what I probably should have done, is pull out the calculator. So get out your TI-84 or your emulator or whatever you have as your calculator. And we're going to input this data set into stat. All right, we're going to put into L1. So remember, stat, edit, going to clear out L2. I don't need L2. So I highlight L2, hit clear, hit enter. And I also want to clear out L1 and replace it with my new set of values. Okay, so there we go. So I have this data set here. I'm going to input that into my calculator. So go ahead and do that now, guys. Okay. So once you have that inputted, if you don't have it yet, pause the video, catch up. I'm looking for the median, right? What is the median here? Okay, so I want to find the median. I hit stat again, go over to calc, one var stats, list is L1, which is good, go down to calculate, and I can find everything I need, right? Here's my mean. I want to go down to find my median, the one that says MED, that is my median. 75. Sweet. So, my median for this example is 75, and we actually probably could have found that just by looking at the graph, right? The middlemost number, well, it looks like it's 75, but it's always good to make sure, right? Always good to check. And what is the shape? Is this symmetrical? Is this right skewed? Or is this left skewed? Let's take a look. It's not really distinctive, right? It kind of looks like it goes up, 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 and then it starts to go kind of back down. So I would say this is symmetrical. I wouldn't say this is skewed towards one side. It's not really like a slide going down to the left or to the right, but goes up and then kind of goes back down. So that's symmetrical. If it's symmetrical, what would be the best measure of central tendency? What would it be? The mean would be the best measure of central tendency because it is symmetrical. In other words, there's really no outliers. So you want to use the mean for this central tendency. Okay. Pause the video if you need to, get down any of the information. And let's go on to the last example. Example 3. The resting pulse rates were recorded for 16 boys in gym class before they exercised. Okay. The plot below says, called a line plot. No, just don't even look at that. It's the same exact thing, right? We use x's. You don't really need to look at this. Whatever. We have x's here. It's the same thing as a dot plot. So, number 1, what is the range of the pulse rates? Answer that now. Again, to find the range, it's the max minus the min. So it's 85 minus 79, which is 6. So the range is 6. Which pulse rate was the most common? Well, answer that now. Which pulse rate was the most common? The answer is 80 and 83, because they both occurred 4 times, right? So these two were the most common out of all the other pulse rates. Number 3, which word regarding central tendency would define letter B? Or number 2. So which word would define the most common? Is it mean? Is it median? Is it mode? Is it range? Remember, most common is the mode, because mode looks like most. Which one occurs the most? Number 4, how many boys had a pulse rate over 81? So it's not asking how many boys had a pulse rate of 80 and higher. It's saying over 81, which means I only care about 82, 83, 84, and 85. So if I look up here, 82 has 3, 83 has 4, which makes 7, 84 has 0, and 85 has 2. Altogether, that makes 9 boys had a pulse rate over 81. Number 5, there are no x's above 84. What does that tell you? Well, answer that, guys. If there's no x's over 84, what does that tell you? Oh, above 84, I'm sorry. Well, it tells us no boys had a pulse rate of 84. That's all it tells us. And then number 6 actually shouldn't even be in here because it's not a proper question. Get rid of that. And That's it, guys. Those are dot plots. Simple, nice, easy to read, and incorporating central tendencies, mean, median, mode, range, all that good stuff. So make sure you send us the notes, and we are all set with this lesson.